Hi everyone, long time no video. Today in this video we're going to talk about substitution, which is a method for solving a system. So as a reminder, a system's when we have a couple equations, two or more, and we're trying to make them all true at once. So what we're really doing here in this first example is I'm trying to find an x and a y value that works for both equations, meaning it makes them both true. All right, so substitution, the goal is to isolate a variable. I want to pick one of the variables. I have an x, a y, an x, and a y. I want to pick the one that's easiest to get alone, okay? And the one that really jumps out at me is this y in the second equation, because really it's just got a 1 in front of it. So I'm not even going to have to divide to get it alone. All I have to do is subtract the 2x. So in that first equation, or in that second equation, I'm going to subtract 2x from both sides. And that's going to give me the equation y equals negative 2x plus 9. Right? So now what I've done is I've created a statement that says y is the same as negative 2x plus 9. So I'm going to take that negative 2x plus 9 and I'm going to substitute it in, this is why it's called substitution, into the first equation for y. So that first equation is now going to be 3x minus 4 times negative 2x plus 9 equals 19. Okay, so I've rewrote the entire first equation, but instead of y, it now says negative 2x plus 9. So now I can go ahead and solve that. So I get 3x plus 8x minus 36 equals 19. Here I get 8x plus 3x is 11x minus 36 equals 19. Let's add 36 to both sides. I get 11x equals 55. Divide by that, I get x. Divide by 11, I get x equals 5. All right, so there's a one big answer there, x equals 5. I've now found the x value. To find the y, I'm going to take that x and substitute that one into the x in my y equals equation. So finally, I'm going to get y equals negative 2 times 5 plus 9. All right, which is y equals negative 10 plus 9, which is negative 1. So I get y equals negative 1. And there are my two answers. X equals 5, y equals negative 1. The way we write our final answer in these problems is as an ordered pair. So x is 5, y is negative 1 is my solution. We'll circle that. Those are the two numbers that make both equations true. Let's try another example. In this problem, I actually already have a variable by itself. It's x. And it's x in both equations. So with these problems, it's kind of like you're just setting both equal to each other. So I'm going to take from my second equation, the 5y plus 12, because that's what x equals, and I'm going to substitute it into x in the first equation. So I get 5y plus 12 equals 3y minus 4. And this goes back to early in the year, so subtract 3y from both sides. And I get 2y plus 12 equals negative 4. Subtract 12. 2y equals negative 16. So y equals negative 8. All right, so now I know my y value. And then in order to find x, I'm going to take that y value and plug it into either one. You get to pick. It doesn't really matter. You'll get the same answer for both. So I'll pick the bottom one, just since that's where I drew my arrow. And so there I'm going to get x equals 5 times negative 8, because that's what y is, plus 12. X equals negative 40 plus 12, which is x equals negative 28. All right. So there's that answer, and then I'm going to write this as an ordered pair, negative 28, comma, negative 8. For our third question, let's go a little faster here. We're going to isolate x in the second equation because that one's going to be the easiest one to get by itself. So the second equation is going to become x equals negative 2y plus 3. And I'm going to take that negative 2y plus 3 and plug it in for x in the first equation. So the first equation is going to become 2 times negative 2y plus 3 plus 4y equals 6. Do some distributing. Negative 4y plus 6 plus 4y equals 6. Well, on the left side, negative 4y plus 4y cancels out, so I just get 6 equals 6. This is true. And when we get a true statement, we're happy, but true is not my answer. My answer is infinitely many solutions. Infinitely many solutions. If you remember back to graphing, this is, if we graphed both of these equations, we'd get the same exact line. So this one is a special case. If we get a true statement, all the variables dropped out, we get a true statement, which means infinitely many solutions. One last problem. This time it's y equals x plus 3 and 2x minus 2y equals 11. I've already got y isolated, so I'm going to take that x plus 3 and plug it in for y in the second equation. So I get 2x minus 2 times x plus 3 equals 11. I get 2x minus 2x minus 6 equals 11. And 2x minus 2x, those cancel out. So I get negative 6 equals 11. That's false. That's no good. So this one is no solution. Okay, so this is substitution. You had 4 good examples there. Try out the classwork. Make sure you get the retention review done. And have a great Thanksgiving break. Thanks for watching.